Yeah, good afternoon, everyone. It's week 4 of the TRP program, and it's March 9. And once again, happy Women's Day to all of the women here. And we really appreciate you and the contributions you bring to the team, to the program. And and also a quick update from our side, or an announcement. We've also opened the first women-only cohort of the CAME program in partnership with Kafiya and Kafiya Financial Technologies, and also the MasterCard Foundation. So it's a fintech focused program, and I'm sure most of you here are already familiar with it. So please make sure to recommend your female friends who might be interested. And also another announcement from our team, the week 4 project is already out. And also the prepayment deadline is March 16th. So we'll be sharing the account detail through email. So please make sure to check your inbox. And as always, we will just move on to the weekly project presentations. Before I hand it over to our technical team, please make sure to volunteer. We need to see more hands. These presentations are a great way to learn and also build your confidence as well. So I'll just hand over to Baba.
Great. Yeah, thanks, Rhodas. So as before, I think it's Monday, and we want to see like how what you guys did, and kind of if trying every week is just more of a startup. So, and Monday is more of a pitch, and just it like when you convince other people, that means like they have given you approval basically, so that you can go and do something with it as well. So try to exactly explain what you have done in short, but I will be timing just so that we give more people. So it's kind of about 3 minutes. So make sure that you kind of use the time effectively. So usually that means knowing 3 minutes is really just very small. Say what you wanted to say early, and make sure that you structure that way, and then you'll have question from the community if they want to hear more. Okay, so given that there are only 2 people whose hands are up, so let's start from them. Okay, so good. So there are more. So what I'm going to do is, as last time, I think we're going to do it 3 minutes. So in any way, we're going to actually just go and see how much we can cover actually. So Darajay.
Okay, thank you. So let me share my screen. So I hope you see my screen, right?
We see your screen.
Okay, 3 minutes on the clock. So the first unit is lead ceremony. So I have after creating the document profiles, there are 3 tiers over there. So one thing I want to mention over here is if the thing goes to vision model, so and then if it fails, I have a fallback to at least, instead of crashing the whole thing, crashing the main loop. So I put a fallback, at least do a lightweight fast text extraction. The next unit is just don't break the tables engine, checking engine. So that's 3 phases. So text and list, table serialization, and figure association. And then I have 5 master roles. For example, the header in row has to be bonded. A figure must have a caption. And then list integrity. I mean, we shall not split lists unless we reach a certain maximum token. And then make sure we have a cross reference over there. And then each chunk has to be validated. For example, if a figure is missing a caption, or if a list is split arbitrarily, so we have to log it. And then the last thing is, I think every chunk is uniquely identified with a hash. So finally we have a LDU, and the third chapter is where am I? I'm in the document map. So once I have the LDU from the chunker, we will have 3 stores, a kind of vector store, and then fact table. Vector stores are divided as math, so we have a fact table for the math, and then vector store for thematic search kind of thing. And then we do LLM enrichment, and then provide that one to the page index tree. 3 minutes is short, so let's fly. So are you trying to me? Are you lying to me? That's the fourth unit. That's auditor. So every question or every query shall not go to the a single store or single database. So it depends on the intent of the question or the query. So if it is a numerical table query, it has to go to fact table. If it is a thematic or text kind of question query, it has to go to vector store. And finally, every reply has to go to the provenance chain. And finally, the audit agent. I think I have a contribution around here. I do integrity check and then a double pass check. I implemented a judge LLM over here to verify my answer. Let's go to the terminal and then try to ask a question. See how it answers. I have a test query Wally. So I prepared 3 questions. So the first question is how many households were covered in 250 assessment. Try to search households with certain filter. Okay, so provides a response, FTA kind of thing. So with this provenance, it's found on page 10. And then another question, how percentage orders provided with this mentioned components provides an answer. So yeah, I think 3 minutes on the clock. Thank you.
Excellent. Okay. Maybe just I will ask one question. What was the most, like, what challenge or what issues like did you have to solve, like, or what were the most challenging, still unsolved maybe, but what are the what have you noticed, what have you observed?
The most challenging is probably 3. The first one is memory allocation. So I was facing main challenges regarding that. Second one is regarding the assuming that I do the pipeline, but what if I want to sell this product to a real client? So how am I going to deal with the cost issue? So when the pipeline goes wide and wide, it might be good enough, but the cost issues. That's the second challenge. Then third one is maybe the audit. Sometimes I miss to provide I miss providing necessary provenances or necessary artifacts with the answers. Maybe yeah, just 3 only. So that means regarding the audit and the accuracy, I would say those 3 things.
Great. Yeah. Okay. So I will give one question to the community. They have. So if not, okay, then to Stefanos.
Okay, can you hear me? Am I audible?
Yeah, we can hear you. You're audible.
Okay, good afternoon, everyone, and happy Women's Day. And let me share my screen and proceed. Is it coming? I think. Let me wait.
Yeah, I think it is coming. Just yeah, we
coming.
see your screen. Yeah.
Okay, now you can see, right?
Yeah.
So to save my time, let me go from the backward. So for this challenge, last week we have been tasked like to solve the traditional OCR problem, which is like the structural failure, the provenance, and also the context aware. So I tried to solve this one, and so that it can be for the non-technical person. For the technical, I have also built the UI. So as you can see, I have the document intelligence refinery pipeline. So one can come here and come put any tasks that he wants to do and do the parsing. So here we can see that we have different kinds of navigation. So here we can find, like, for example, for the pipeline view, we can see how much, what kind of parsing that we do from each stage, the results, like from triage, extraction, and so on. So this one will be more beneficial for the technical person, so he can get the detail of what we have already done. And also we can see the details of the chunks, the like what kind of chunking we do, and so on. And also we can see the indexing here. We can find the tree structure right here, so that we can see here what kind of structure we do. And also for the non-technical person, we can find here a query interface, so that he can interact Q&A. Like, for example, I have asked here, how many employees does your organization employ? So it tries to do
you can close, you can X your Gmeet window. It's fine. It's still fine. Okay.
Yeah, nice, fine, right?
Yeah.
Yeah. So like it's a chat interface so that a non-technical person interact and ask like that. So here, as we can see, I have asked how many employees does our organization employ. So it's trying to do checking. It tries to search from there, and from that on, it will give us the most relevant parts, and from that, once the LLM is synthesized, it will give us actually the actual answer. And also we can have like a quick audit mode. Here also, like, we can come and ask like fast quick checks instead of a question and answering. One can come and like ask, for example, have the built-in questions. One can come here and ask like some claims, like to check it, so as you can see, it goes and searches and like it says like it's supported 80%, and also it gives us where it actually does it get all this like in supporting evidence like that on the situations. So I think it's pretty much the user interface. And when I come back and try to see the implementation, here I have like source file where I implemented all the agents and like that. And let me quickly show you like all the artifacts that I have already generated. So for the profiles, if I can come here and like see, we can see for the profile for every PDF that I run. So you can see the details of like the layout complexity, extraction cost like that. So after this one, the chunker will also go and like generate all these chunking files. So as we can see here, we can get the details of like what kind of document it is that we parse and so on. So we can see the bounding box and everything pretty much here. And this one is the chunking document. And if I come and see also the page structure, and we can see here the tree that like the document is. So instead of like searching, we can find like the tree here. So it has also built it here. And we can come and see also the extraction ledger. Here we can find like the audit where we can easily navigate what kind of things that we have done, and all the audits, it will put it here. So it is like pretty much saving everything. And also like
I have to stop you. While actually I kind of passed the time. So okay. So great. Thanks. I think just given the time, just I would kind of, we can come back and ask. But if the community has one question, I would allow if anyone has one question. But great. This was good.
Okay.
Okay, so if not, what I would probably ask is that, have you actually had time to validate that the actual, you ask something, and if there are, like, for example, in two places, conflicting values, or, which one would it proceed and how does it work? Like, so did you have a chance to look at the result?
Okay, for me, what I have already done is like, because the LLM code was not working for me because I ran out of like the cloud API code, I was trying using a single page documents and like page documents like 40 like that. So for that one, I have tried to test it, but for like documents longer than and like any conflicting situations, that one I have tested out because as I said, my LLM was not working.
Yeah.
So that one I have not worked. Yeah.
It's fair. Great. Thank you. Thank you, Stefanos. Okay. So then to Nabil.
Okay, let me share. Can you hear me?
Yeah, we can hear you.
Okay, so I'll just go through quickly what's a bit different from the requirements that I've added. So this is just to show the routing strategy. In the routing strategy, depending on the type of, the origin type, we can go to the fast text, the layout model, or the vision model. But one thing that I've added here is some pages may have like mixed properties, so we can still benefit from, let's say, like the fast text strategy rather than going to the vision or going to the layout. So page by page, I have changed the algorithm to check that specific page to allow us to use a lesser expensive strategy. And I was able to do this by pre-computing the refinery, I have the output using PDF Plumber. Let's say for this document, for each document, I have pre-computed the character density and the properties of the page. So this way, the code loads this section or this JSON for that specific file. And for each page, it can check what type of property it has. So some pages may need layout. So we don't want the entire thing to go to the layout pass. So this would allow us to go page by page to use a less expensive extraction strategy. So this is one thing I've added. The next thing is a fallback strategy for the LLM and also the other strategies. So if you have like multiple failures, it can handle this. So if the LLM fails, you can have multiple agents, multiple LLM models configured, so it can go from one model to the next and then to the next. And if that fails, it will go back to the layout or the OCR. And then if that fails, also to go back to the fast text. So these are basically the two things I did that are a bit different. The others is just basically the same architecture as directed by the document. So thank you.
Okay, so you have 1 minute as well. So can you demonstrate how the performance
Yes.
of it? So
Yes, of course. So just I have prepared a command here actually. I call this pipeline papermind AI. So I've developed a CLI for it. So it takes in lots of commands. Ingest, query, and ask are some of it. So we can ask it a question, and then it can answer a question based on the references it has created to come up with sources. As here you can see the LLM fallback. So I always try to get Gemini first, and then falls back to Anthropic. So it gives us the answer, it gives us the page. Another thing that we can do here is papermind audit. So this is a false statement. I can show you the page, but this is a false statement, and now it would provide sources and would provide like, is it verified? Is it unverified? Is it contradicted to what our data says? So here I have provided a false statement and it shows us contradicted. So the statement here contradicts whatever is in the data of the page.
okay, and maybe okay, great. So I think that's good in time usage. Anyone has question?
I have one question for him.
Yeah. Go on.
So Nabi is good. How do you check the integrity? That might be helpful for me too.
Integrity of the data.
Yes. Once the LLM provides the answer, so how do you know? How do you audit it, or how do you recheck the integrity? If that, for example, if that hash is available in the fact table or not, kind of thing.
Oh,
To protect
yeah.
if it's guessing or hallucinating, how do you check the integrity?
Yeah. So what I've done now so far is like to manually check it. I didn't implement a way to check it. So here specifically on page 46 and 47, it talks about awareness. The direct question that I asked here. So you see the sources, page 46, 47. It specifies that part. So I just manually checked. I haven't built feedback that would check the quality of the data. Yes.
Yeah. I see content hash on your response.
Yes.
I think on your
Yes, there is a content hash.
Yeah, of course.
Yeah,
you probably could compare the hash. I would recommend that.
okay.
Yeah. Hash. Yeah. Thank you. Good.
Thank you.
Excellent. I mean, the quality of the work you guys did is great. So, come back together as well, just to discuss, to bring together, all of the good stuff and kind of open source, at least with, as contribution by a number of people. So I think that this is going to be very useful for a lot of people. So great. Okay. Thank you, Nabil. Then Brikti.
Good afternoon, everyone. And let me share my screen. Okay. So the main problem we're trying to solve is that most important information are buried in PDF, and traditional systems loses structure or context. So first, let's start with the architectural overview. And so the system is designed in modular pipeline. And the first one is the triage agent, which first profile the document profile, whether the document is native or scanned, and layout complexity. And based on this, the system extract the cost, and the extraction router then, based on the document profile, select the most appropriate method of cost and flexibility, and select the best tools to use. And there's also the semantic engine. Once it's extracted, the content is then converted into list of into logical document units, and this step is crucial. And there is also the knowledge layer, and this one, instead of relying on embedding, the system also builds multiple knowledge layer, which is the page index tree, a hierarchical navigation tree, fact table, which is the key value facts, and the knowledge graph, which is entity linking, so that these facts and entities have can be identified as relationship. And also for semantic similarity, there is a vector embedding. And then there's the query agent, which answer the user question instead of relying on one retrieval method, and also uses the page index, semantic search, and structural facts. And with the provenance chain, it answered the user question. So in short, this system transforms unstructured PDF into structured knowledge that can be navigated. And when it comes to the implementation, the entry point is the CLI, which uses to run the PDF path and parses the argument and calls the orchestrator. And the orchestrator also is the pipeline controller, which executes all the stages. So to see some of the artifacts I generated. So for let's go here, and for this document, we can see that the native is identified, and also the layout complexity, and what kind of domain it is, and what kind of cost it needs. And then there's the facts here, which is key value pair. And then the knowledge graph, basically entities in their target and their metrics, and LDUs here also, which classifies them by paragraph, by section, things like that, and page index. And I also try to ask about this document, and based on the question, it also provides an answer with confidence, and also tools that was used, and with hashes, and also with the correct answer, which I manually checked this one. And this is my implementation.
Great, thank you. Good. Anyone? Any question? So one question from me is that, so have you implemented the knowledge graph, and was it able to improve? Like, was it used in your as tool, for example? Did you see its improvement?
Yes. The reason why I added it is for complex and ambiguous relationship. Even though I didn't put all that PDF, it's important to identify the location, the people, the location in matrix, and things like that, so that for the query agent, it uses for knowledge layer for
Yeah, but
providing.
how is the knowledge graph constructed? Is it
So I use lights with like regular expression and things like. I didn't use any models. I used it to test using lights with regular expressions, things like that, to identify location and organization.
okay? Okay. Good. Thank you. Thank you, Brikti. Rafia.
Afternoon, everyone. How are you doing?
Good afternoon.
Am I audible?
Yeah,
Okay.
you are.
Okay, let me share my screen. Mhm. Is it visible?
Yes, you're visible.
Okay, so this is the architecture I with my teammates came up with. So this is after the input, the triage agent classifies, and after the classification, if the classified project is native digital, it will go strategy 8. So after confidence check, it will be escalated to the strategy B. But if it is low confidence and if it has scanned in handwriting, it will be escalated directly to the strategy C. So this is the escalation architecture right here. So yeah, this is my architecture. Since I have a very short time, let me go through the implemented pause. So I tried triaging it. So the triage command, it classifies the document. Here we have the file name, the origin type, and the page count, and the extract command in meme file does extract the file, and it will output the strategy it used. It is the fast text with confidence 82%. And after the extraction, the extracted document directly gets pushed into the output folder. The JSON file, the text file, it will be inside output. The text file is like the human readable version, and the JSON is the main content. So the outputs will be it will be open in here. So the last thing is like index, the index command. So the index command will output this like it is indexed, and the summary of the introduction will be the node, and the other main file would be here. And so yeah, this is basically it to be fast. So to ask my to share my main challenge in this project and ask for help is that where I perform extraction quality, the original documents were in PDF format here. So the original was in PDF format. These are the main for the original files. So the extracted outputs were in JSON in here. So the JSON, so which made computing precision and recall directly a real headache. I even tried converting the PDFs into JSON for comparison, but the converted files ended up being identical to the extracted JSON, making the analysis ineffective. This highlights a key challenge. Aligning the different data formats for meaningful quality metrics is often easier said than done. So this is my challenge, my execution, and my architecture in short. I hope I used my time effectively. Thank you so much.
Great. Thank you, Rafia. Anyone has any questions, Rafia?
I have a question.
Yeah, go on.
Okay, maybe Rafia, like, have you tried out using long text documents or long PDF files? So when you tried DocLink, have you faced this memory running out of error? If so, how did you fix that?
No, I didn't face a long text problem because each document is split into smaller manageable chunks. So I performed the operations in a chunky document. So no, I didn't run into this challenge.
So maybe like rephrasing the question. So if you have a 500-page document, what does it do? Rafia. So
yeah,
if you had a 500-page document, you give it now to your pipeline, what does it do?
So I think it chunks it before embedding any semantic file.
Yeah, but like the extraction. So that one is like after extraction. But while it's extracting, it sometimes needs to like understand the whole document first, right? So page by page, and it's going. So how is the pipeline
Okay,
gonna work?
for extraction, the 500-page doc flows a bit differently, but the idea is similar in terms of scaling. So for triage and profiling, first the doc is scanned page by page to figure out type. After it is scanned, the basic status, page count, and the structure hints. So after per page extraction, each page is processed separately by extraction strategies.
Okay. So that means you are coding actually your doc link on a single page, like therefore, and then you then go on into the next page, and then that one could be fast text or like that. So it's kind of you, and then at every stage you are kind of saving that document, like that extraction.
Yeah, it is not for every file, but if there is a big file like with more pages, I wrote a logic to do page by page extraction, and it will merge after the document is fully extracted. It will merge it, but it is not for every single file. Like for files with 15 pages or 20 pages, I don't use page by page extraction. But if it is above 13 page, I do use page by page extraction, and it will be merged after every page is extracted.
Okay. Yeah, just good to try, because I think that one is one of the main challenge actually. So just try at least try to see the memory grows as it goes. Okay, great. Nuriye?
Good afternoon, everyone. Am I audible?
Yeah, you are.
Okay. So let me share my screen. Have you seen my screen?
Not yet. Yeah, now it's good.
No,
So
it's good.
see your screen.
So thank you for the opportunity to present the project, actually. So this project is just an end-to-end document intelligent refinery system. It's just designed to convert any document into structured knowledge and answers. So the system supports multiple document formats, including a PDF, a docs file, Excel file, markdown file, and images too. So this is my architecture, actually, from end to end. So as we know, many organizations these days have a lot of documents and even large documents, but extracting information from them is slow, inconsistent, and sometimes impossible. So documents may contain complex layouts, tables, and scanned pages, or even mixed formats. So the ordinary single extraction method may not work good. So I'm confident that this system can solve this problem, as it is modular and have different processing strategies. So the first, this refinery system have 5 stages. The first is the triage stage. So in this stage, we can able to see the system analyzes the incoming document, and then it identifies the file type, the page count, the layout complexities, the text density, and any other information that are important from the data. So based on this analysis, the system just predicts the best extraction method. It may be strategy A, strategy B, or strategy C. As I can say, so this stage helps reduce the processing cost and improve our accuracy. So as you have seen, all the data have been listed. And the second stage will be the extraction stage. The extraction stage is happen after the strategy has been selected from the stage 1 So the system converts just the raw document into structured representation. There are three extraction methods. Strategy A, which is a fast text-based extraction method, which is for simple data, and strategy B, it uses docking for more heavier data than the strategy A used. And the other is the OCR pi-tesseract model, which is used for heavy and complex data types. The other is the semantic chaining. So once the document is extracted, the system divides the content into logical units, and instead of splitting just texts randomly, it keeps related contents together. So I believe this stage helps to solve the real-world problem called improving retrieval quality and structure of the document, and also it keeps the meaning of the document. The other stage is the indexing. Here in indexing, we have three storage mechanisms: the vector database, the fact database, and that of the page indexing. So this is the stage where
In the interest of
retrieval
time,
quality is improved as much
I
as we
will
can.
stop
So
you. Nuri,
the system creates three different.
hello. So
What?
just because the interest of time, so I will stop you here,
Hello?
and then I will see. Hello, can you hear us?
Yeah.
Yeah, just because now you are at 4 minutes.
Okay, the
So let me
result.
stop you there. No, I think let's stop here because
Yes,
like
I'm
it's
here.
3 minutes. Yeah, it's 3 minutes. So
Okay.
and
So
then let's see if
you want
other
to see the
people can
output?
ask you. It's the time, like because of the time, I'm kind of stopping
Okay.
you, and then if other people can wanna see the result, then you can show them. So anyone can ask question. Rie?
Okay.
Let's see the output.
So Nuria, just Abdulhamid wants to see the result. So can you show the result?
Am I audible, guys?
I think it probably it's delayed, but do you hear us?
No, I'm hearing you. Yeah.
Yeah, I think it's delayed. So show us just the result, and then let's finish it there.
Okay. Can you see the result?
Yes.
Yeah. So this is the question and the answer. Even have cross-checked with the current document. All the answers has been found in page 84. Everything. I'm not sure if the network is weak.
Yeah. I think it's just delay. I think the quality is good, but the quality of the network is good, but it's just a delay. So latency only. So great. Okay. Thanks. And then let's go to better.
Good afternoon, everyone.
Good afternoon. Yeah, go on, proceed, better.
Okay, I'm sharing my screen.
Okay.
Can you see my screen?
Yeah, we can see your screen.
Okay, so as everybody said, I'm using the same architecture, like uploading the PDF. Then there's the try generating, which is the document profile. Then there's origin type detection layer, complexity, confidence, and strategy. Then the extraction layer will continue, which is the choosing the strategy of every page routing. So there's vision, which for vision extraction, I'm using extract. Then for layout, docking. Then for this PDF member, then normalization. Starting. So first we will chunk what we got from the structure layer, then validate it. So in this part, I try to upload 2 files and see whether those 2 files are related by using relationship graph builder other than the page index. So then after building the page index, the relationship, and storing in vector store, we go to the last stage, which is the querying the provenance. So for demonstration, so this is the part where I have uploaded 2 files and try to see whether the 2 documents are related or not. So we can download the image and see if they're related. It's a bit messy. I'm trying to like optimize it and make it better. Thank you.
Great. So what is the graph showing? Like, what's the entity relationship by entity? Is it, so in your architecture, if you go back to your architecture, so you have the page index, and then that goes into relationship graph builder. So is it there that it actually identifies from the context entities?
It's from the logical documents unit.
Yeah, exactly, from kind of the chunks.
Yes.
So from there, it identifies entities, and then it forms
Graph.
relationship with existing entities. So let's say you are at page 1, you know, you have done that, and then you are now at page 10. So will it try to relate?
I tried using these 2 documents, not this one. Whether for instance, whether if these 2 documents are related.
Okay, so the entity relationship is just you select 2 documents, and then you see if there is relationship.
Yes.
Okay, so this is a type of a feature, but you could also do within one document some entity relationship knowledge graph.
Yes, but for that, I thought we are already using since we are already using the page index, it wouldn't be much.
But is it? But it's not entity, right? So entity is different than page. Yeah, but okay, great. Thanks. Yeah. Anyone has question for Betel? Okay, great. Thank you, Betel. Maseret?
Hi everyone, good afternoon. Am I audible?
Yes, you are audible, and we can see your screen.
Can you see me my screen? Can I see that? Okay, so here was my the whole architecture I tried to implement. So we have a raw PDF, and we have everything will be detected as either it is digital or scanned, and it will be detected in language because some of the files was Amharic, and will estimate the extraction cost. So here what the whole architecture is based on the confidence. So if the Amharic is native digital, it will scan it with confidence 0.95, and if it is English, everything will be extracted here. And I have as on the document shared, I implement with
okay. Sorry. Like I'm confused. So why are you like setting the confidence at that? Like
which one?
So in your architecture, you have Amharic,
yeah.
and then you have just set the confidence. So are you estimating the confidence, or is it just set?
If the Amharic document is scanned well with high confidence, it will extract mainly most of the scanned documents for Amharic wasn't extracted well. It was just detecting as a language. It wasn't extracting the whole Amharic letters. So that was the fail. That main thing that my system failed. I will show you that. And those are the 4 rules I implemented. Tables will be standalone, so it will be extracted. Like let me show you the the whole architecture what I did. So first I took this raw normal PDF and everything is here. The language will be detected and the extracted files and the LED, the clean layout will be here extracted. And even if, as you can see, the Amharic here is extracted well because it was normal PDF, and if it's not a scanned document, it will extract it, but it wasn't working for those scanned Amharic PDFs. And the PDF indexes everything is here, every detail. Sorry. Yeah, there are like almost 155 pages and everything is here. And they carry, and I just asked this question, and it was extracting based on the document file and the everything, the page and the result they got, like for what are the main findings about local government financial transparency, and it extracted those results and with exact page locations. And for the big time, I just run it here. The whole strategy, the ATQs, the confidence, and the confidence helped me to have high extraction file, like to extract those files properly. And I pasted those page index for those for this file, and everything will be extracted here on the profile. And let me show you the profile for this file. It's like native digital and with multi-column, and the language is English, and with page count and the character per page. And if it needs like a payment or cost, it will notify it here. It doesn't need any cost, so everything is extracted here, and that's what. And the thing that I couldn't implement is the Amharic, like I said, the Amharic language wasn't extracting well, and also the language detection silently turns null for all scan documents. So at the first, I faced this challenge, but I implement that lately. And the multi-year.
Let me stop you. Okay, but then you can continue because I will ask you. But then just let me stop the time. Okay, so just finish the failure, and then
okay.
Yeah,
so mainly like first there was a failure in each steps. Like on the change agent, it was like the language would be detected, but it was showing me a null. Like even if it's Amharic or English, and first I was facing that, and after that I tried to use some of the model. I forgot that it was highly good for the Amharic language. It was detecting that, and I just tried to implement that, and those are like the main failures I faced. And still, I didn't implement that, and I will try to solve that.
Great, thanks. Okay, and one question to Maseret from the community. There is. Okay, if not, thank you, Maseret. Johannes?
Okay, can you hear me?
Yeah.
Okay. Okay. So if you can see my screen.
We see your screen, yeah.
Okay, so to start my good morning, everyone, and all my colleagues. So for the project was document intelligence refinery. So what I did different is first I implemented a confidence gated escalation guard instead of a one size fits all approach. The system now routes documents through a non-linear logic. So I attempt zero cost local strategies like fast text first, only if the confidence drops only to below 0.85. So if it falls below that, it escalates to local OCR or high cost VLMs. So the single architectural choice reduced our projected API overhead by over 60%. And second, I moved beyond naive vector search. I built a custom hierarchical page index by mapping the document spatial layout to its logical structure. The agent can navigate by reasoning, like jumping straight to an income statement rather than just matching keywords. So this effectively kills the context poverty that causes RAG hallucinations. And finally, on the resilience side, I hardened the strategy B recovery. I found a pathing failure in the OCR engine and refactored the router to validate binaries at runtime. So now 92% of our scanned pages are handled locally and with our new atomic persistence logic. We no longer risk data loss during large 12 documents. So the achievement is 217 page sprints. I processed 12 diverse documents. So to show you my artifacts, so these are the 12 documents of the 3 classes. This is my extraction ledger. As you can see, somewhat different. The different thing here is that it decides first before it goes through the pages. So the triage decision for this file, for example, it's strategy C. But when it goes through each pages, it might change the strategy according to what kind of document it is. If it's a scanned image, it mostly goes to strategy B for the local OCR. And these are the profiles for each document. And these are the page index files for each document as well. So I can ask it a question now. This is my CLI query. I didn't implement a user interface since I didn't get the time, but I can ask some question here. And it replies by its provenance, like referring to the document. It has to. So it referred to the document and gave me the informations I needed. So yeah, that's it. Thank you.
Excellent. Thank you. Anyone want to ask question? I think it's yeah, go on.
I have yeah. Thank you, Johannes. It's a good work, but one thing to follow. Have you tried to parse scanned documents or handwritten documents on strategy C? If so, what kind of problems have you faced using VLM models?
Yeah, I was trying to use local OCR for scan documents because after the Standup, we talked about to use strategy B mostly to, effectively use our cost to save our cost, but it was constantly going to strategy C for every document. That was the blocker I encountered. Strategy A or strategy C. It was not getting the local OCR, which is the Tesseract. I used that, but when I fixed it, it only goes to strategy B after the scan documents. But if it encounters like complex images or pictures, it only calls the VLM models in that way. And I was able to reduce my cost very drastically by doing that. I think I answered your question. I hope so.
Yeah. I think Estefanos is thumbs up, and as well Masara. Great. Yeah, awesome. And great. So then let's go to Yosef. Yosef, are you?
Yeah, hello.
Hi.
Okay. Okay. So, okay, let me share.
So I think, like for the community maybe, or I'm not sure for who, Gambria is asking, how did you insert large vectors basically in your database? So anyone can ask in the in the chat. Go on.
Okay. So my PC is a bit lag. Maybe yeah. So I created this front end, but the logic is the thread will classify the documents, and the router will choose the strategies between the three, and the extractions for the heavy materials will go to the doc link, and after that I'll provide the chunking and create the chunks. After that I used the indexing to index, and then I used the query, and so after I give the document, it gives me the document profile, and if there are blocks, so here are the refineries, and the profiles are here. For example, is created like this, and also the extractions also are like this, with the content, the bounding boxes and numbers, and also the indices are also here with the document ID in the root, if the root, and also if there are the child sections, and to connect. So after that, there is the query. I try to connect the page index with the vector database and to query. So it's depend on the documents. One thing also FS the LLM is output is most of the variable, and for example here it extracts and it gives me, but it also sources the page numbers. For example, the reflection on the document, and give me these kinds of results. I also tested it by scripts, and here are, for example, if I ask the question, it provides the answers. It gives the sources, and for them, on some questions it gives provenances, but for them it doesn't give, but it gives the sources. I'm trying to run it again, but I think, yeah, as for now this is working. I used this financial document. So if I type maybe the document, sorry.
It's fine. So in the meantime, just let me stop the timing, and we know we have seen your output. So anyone, any questions, you can type in the meantime. So you can, it's fine. So it's just while anyone, if they have any question.
Can I ask?
Yep, go on.
Did you use like for the extraction of those scan document, like the OCR? Did you use that?
I used for the scanned documents. I use the Queen model or Vision 3, like for the strategy C, the Vision for Vision model. So it's extracted some documents, but the accuracy is low, but it extracted the documents. But for kind of tables, I use a docklink, and when it saves, for example, after extraction, here are the blocks. The blocks save the documents, but at last, here it saves it like this. The tables, like where is it? Yeah. So the header, which are this, and the rows for the 3 columns are saved like this for each column. So the tables are saved like this, and the documents are also saved above. And so the extraction is by blocks and by documents, and yeah, like this.
Okay, great. Thanks. So let's just proceed to Ahmed then.
Okay.
Okay, thank you. And good afternoon, everyone. Let me just share my screen. Can you see my either?
It may be, yeah, we can see your screen. Start. Yeah.
Okay. Okay, so let me just go to the mermaid diagram. So we have the 5 stages pipeline. So we accept the PDF document. Then in stage 1, we have a tri-age agent, which runs the job profile by Danik. Then in stage 2, we have the structure extraction. So we have extraction router. If first it goes to like fast extraction strategy 1, and if the confidence is acceptable, it can generate the extract documents by Dynamic. Or for strategy B, yeah, we have strategy B, and if it all bugs from strategy A due to the confidence, it can go to strategy B. And we have also the strategy C, that's the vision. And then in stage 3, we have the chunking engine. Then we have the stage 4 page index. We have optional vector store in addition to the page 3. Then in the final stage, a query, and we can ask a question and check whether for this correct answer. So let's just check the structures. We have the IDs, which produce structures, and in the page index, we can see how it's structured. Then in the profile, the tray agent part, it produces structures. Let's just run the demo. So here we are asking like some random question to one of the PDFs, and also checking the claims. Let's just run the PDF.
Yeah, it might take some time, and the time is on all there. So yeah, is there any question? Ahmed?
Yeah, let me ask him, I think, a question.
Yeah.
So, Ahmed, as we know, our system needs the page indexing, the ChromaDB, and the SQLite in the indexing stage. So, what limitation do you think will appear if we use only one of them? Like, what is really the need of using all these 3 databases?
I think it's mostly it's for the quality and the audits, because like it can refer the source that we get from the page index may not be like accurate 100%. So maybe for just cross-checking the facts. So I think we have the result here. Yeah, the artifacts are saved in these files. Then we have the question, and we get the answers here, the province, citations about the claim we made here. It's verified as true. And that's
great. Yeah, thanks. Thanks, Ahmed. Okay, so final, let's go to Abdurrahim.
Yes, hi everyone. Let me share my screen. Is my screen visible?
It's probably coming, yeah.
Okay, let me know if it is visible.
Yeah, it's not yet. So maybe reshare it again, unshare and reshare because it's not coming. Yeah, okay, it's now, it comes.
Sure.
No, it's fine. It comes, continue.
Okay,
yeah,
sure.
you can see your screen.
Let me go to my architecture. So let me simply go through it. So we'll have a raw document first, and the triage agent, identifies the document profile and pass it to the extraction router. And if we go to my code, there will be a profile for each document, so which will be stored here. This is just the agent state profile, and we'll have a log in the profiling ledger. So we'll have more metrics here. So layout complexity and stuff like that, column ratio, and so on. After that, it will pass to the right extraction strategy based on the document profile. And once it is passed to one of the strategies, it will be based on the confidence, and it will escalate to the next stage. We can show it here in the extraction part. We have extraction ledger for each input. So let's say we have, I think these 2 lines are for one document. So the first one is background checks. So let me go to, so it is escalated, as you can see. The final disposition is escalated, so it is passed to the vision layer. In here, if we can see the confidence here, the confidence score is 0.88. First it was 0.45, so it escalates to the next strategy. Also, one thing I want to show you here is we have extraction rules. So for each stage we have extraction rules. We can edit it as we want. The LLM models, for example, the vision uses auto model, so it chooses by itself. For the summaries, I think it is GPT-4o, yeah. And we can edit, anything, the confidence, the thresholds, and so on. After that, it will pass to, the normalized extracted document. This normalized extracted document will be passed to the semantic chunking engine, which will do, chunking ready, page, query ready chunks. We can see the outputs here. So we have the extracted document here, and we have the chunking ledger here. We have chunk count, doc ID, and so on, the processing time. Then it will pass it to the page index builder, which will create the vector DB and the page index tree. And as well, we can have a look at it here. So here is the page index. So it will also create the summary. Here it is. So it will create a summary for that document as well. Then next we have the query agent, which have 3 tools bind to it. So the semantic search, the page index, navigator, as well as the third one SQA light DB, query. So to use the 3 tools as it wants, as necessary based on the query we input. So yeah, that's it.
Excellent. Okay. Anyone want to ask question? Dr. Rahim? Okay, if not, then let's stop like today. But I must say 2 things that I have observed. One, really good, right? So one is almost everyone had a very clear voice, and that has a highest return on your presentation, right? So if you didn't have you did the work, you did amazing work, but if you don't have sometimes very good quality of voice that as you speak it, people basically would just not hear. And this is one of my observation. Normally it doesn't happen. Some people have, I don't know, for some reason, just their internet or something. It was great. It was very clear, everybody, so make sure that is one real factor. So, on top of your work, like the medium that you present in it is very important. And another one, even if we are not right now forcing it, we'll start forcing it maybe around week 10, is switching on your video during an actual meeting. Now we're not doing that because of also bandwidths. Like for some people, it might be a lot, but it's important when you are at work to make sure. I think we have Johannes, when he presented, he actually put his video. That's very important. I'm not saying that as an optional or as a good to have, but you have to know that it's almost a necessity that you actually also switch on the video when you present. And so that's, so those are really 2 things that you should take in mind as you go on. And what I have seen today is excellent. Like I think in almost everyone really completed in a kind of in a complexity they managed to do, and really well done. And I can tell you that what you have done really with a small amount of work, and also combined, you can really create something that other people want to use. So you can open source it, advertise it, and even kind of charge for it sometimes, like with advanced features, right? So things like this, we know that we don't have time and we will just pass them because for us it's just a 1 week, and then we have to go to the next another battle. But know that that doesn't mean the value is less. It just means like, yeah, you don't have time, but this is for most companies, what you have just done is an incredible, powerful tool. You can just, you have seen it, you can deploy it, and you basically give them data. And for most of them, it's just really directly relates to their productivity. So just as that because we have to move from one to another project, it doesn't mean the value of that is just as, the value of 1 week. It is really valuable, and you might probably, you will see it over time. But yeah, so make sure to think, to reuse, and to kind of combine the tools you're building as you go on as well. So, have you run, for example, the previous evaluation code base on this one? So try to, at least, even if it's not a lot, but just try to combine them so that it's almost always like you're building some kind of a more streamlined product at the end. Okay, so well done. Really, I'm happy with the progress and with the kind of achievement you have done, and also there's the number of people who want to present. So congratulations for that. So we are just 20 minutes over time. So let's take 5 minutes so that